Is this visible? Hello, is it visible? Is this slide visible?
Yes, sir, visible. Yes, sir.
Okay. Until now you have learned the 8085 and 8086 microprocessors. So next is your advanced microprocessor, which I need to discuss. But before the discussion of advanced microprocessor, any other advanced microprocessor like 80286, 486 and Pentium, the processors, etc. If most familiar with memory concept like virtual memory as well as the cache memory. Okay, so today I'd like to discuss about these two memories, virtual memory and cache memory. Without the clearing this concept, you can't understand the architecture of 80286 or 486 or Pentium, the most advanced processor. So that's why we need these two memory concepts. Okay, virtual memory as well as the cache memory. So let's start with the discussion now. So here, this is the memory hierarchy diagram, where you can see that at the lowest position in this bottom section, only the secondary memories are there, and after that the main memory, and then cache memory, and then the internal memory. So according to these three arrows, like the speed of secondary memories, like as for example the magnetic disk, optical disk, hard drive, these are the secondary memories whose speed is much slower compared to other memories, whereas the capacity to store any information within this secondary memory is the highest. And as well as due to the low speed or slower speed, the cost is minimized here. So when you go into this diagram, the memory hierarchy diagram, the topmost position maintained by the internal memory, means the registers. Those are used to store the temporary results or any data bytes, which is when a computation is in progress. Okay, so basically these internal memories are high speed registers used inside the CPU. So these registers hold basically the temporary results of any program. So there is no speed disparity or speed mismatch between these registers as well as in the CPU or the processor, because they are already fabricated within the same technology. So these registers are actually inside the processor within this chip internal. So that's why any data byte transfer operation or for any read write operation, it will be much faster compared to the other external memories. These are cache memory, main memory, secondary memories are here. Now the secondary memories are it has the very slow speed and low cost device that provides a backup storage, like if you would like to store a large or bulk amount of data, you can use it. Okay, so this type of memory actually used for storing all programs and data, as this one is used for bulk operation. Okay, so when a program that is not residing in your main memory means the RAM, ROM, so these are. So basically when any program that is not present inside this main memory, but it is needed to execute. Then it is transferred from the secondary memory to the main memory. It is transferred to secondary memory to the main memory. The programs are not currently needed in main memory. That means these are transferred into secondary memory to provide space for currently used program and your data bytes. And after that, the main memories, actual main memories are RAM and ROM. Those are used, and these are very slow responding device compared to the processor. But directly processor means the CPU can communicate with the main memory. It can directly communicate with RAM and ROM for any read and write operation. Okay. After that, the high speed memory, that is the cache memory. Cache memory, it is the high speed memory between the CPU and the main memory. It is always used between the CPU and the main memory, so that what is the use of this cache memory? Cache memory, actually it is one high speed main memory. This is actually used when there is a speed mismatch. Okay, because RAM and ROM, these are slow responding device compared to the CPU. So but cache memory, it has the same cycle, timing cycle is just equal to the CPU, so that if any data byte or any program is transferred from cache memory to CPU, that will be processed in very faster way. So that's why, so this is a special high speed main memory, cache memory actually, that is SRAM or static RAM. It is one type of example of cache memory, sometimes used to increase the speed of processing by making the current programs and data available to the CPU at a very higher speed or rapid rate. So generally, the CPU is faster than the main memory, and thus resulting that processing speed is limited mainly by the speed of main memory. So a technique that is used to compensate the speed mismatch between the CPU and the main memory, where it is used and extremely so that technique should be uh, connected in such way that the operation between the CPU and the memory will be much faster. Okay, and as well as the size will be small. So your size must be small, but the data or the program that must be processed in very faster way. Okay, and the access time between this cache memory, access time of any data bytes or program from the cache memory is just very close to the CPU or processor, so that there will be no speed mismatch and the operation will be carried out in very faster way. Okay, so there are different types of cache memories are available, like according to the specification. I will discuss about these types of cache memory later after certain slides. So there are certain levels, you have to maintain certain levels, and based on this level 1, level 2, different types of cache memories are or have to be connected with the CPU. Okay, so the next slide is the connection between the CPU and the memories. So according to this diagram, all of you have seen that main memory, which is the RAM and ROM, that is to be connected to the CPU, and where is the registers, that these are the internal to this processor, and cache memory, that is to be connected directly with the CPU and with the main memory. Okay, so any data byte which is shared by the cache memory and CPU, it is just copied from the main memory. So it takes from the main memory as well as inside it, stores inside it, so that when CPU requests to process any data bytes of program, first it sends a request signal to the main memory, or it is searched to this main memory as well as into the cache memory. So if that data byte is present inside this cache memory, so that will be processed first. Okay, and if there is no data byte which is requested by the CPU, or address is not matched, so it goes to the main memory to search for that particular address and data, and then it taken by the CPU and process it. Now between this main memory and the secondary memory, there is a IO processor. Okay, so every secondary memory devices must be connected through the IO processor with the main memory, like your hard disk or any type of CD, DVD. These are the secondary memories, that these are must be connected through the IO processor with the main memory. So that is the interconnection between the memories and the CPU. And here, how the cache, so let's start the cache memory, the discussion about cache memory. What is this and how it works, or what are the different methods to implement it and techniques, so that your CPU or processor execution time will be much faster, processing time will be increased. So here is your CPU, this one, where the internal registers are there, and internal registers means the memories actually, because memories can store certain data bytes, and register is also stored certain data bytes. Okay, so both are same function, both has same function. So these are internal, and the RAM and ROM, the main memory, that is the external of the processor. And in between this CPU and this RAM ROM main memory, you need to connect the cache, like L1 cache, level 2 cache, level 3 cache. So in this way, based on the operating system, different types of requirements are there, and most as one processors, you need certain increment or advancement of certain technology, and in this way you can connect different level of cache memory. Like for every cache memory, different types of different versions are available according to the size. Like in this way, which is closer to the CPU, that is to be connected. Suppose this is the motherboard, and which is connected very close to the processor, that must be very less, it has less capacity to store the information, which is 64 kilobytes. Okay, then another cache memory which is connected after this L1 cache, which is far away to this CPU. It has the second largest capacity, which is 256 kilobytes, and which is far away from the CPU. The distance is very large distance, so it has the highest capacity to store the information, which is 2 to 4 MB, and that is the level 3 cache. And so all these are connected between the main memory and the CPU, so that the main memory is connected with this one, and as well as with the CPU directly. And after that, when after this main memory, the IO bus is connected to the secondary devices, or disk storage, which is either 4 TB, or from the 4 TB to 16 TB of different sizes availability. Then what is the cache memory? Basically, cache is a small and fast buffer between the processor and the memory. Okay, so that old values, where and how it is implemented, the old values will be removed from the cache to make space for a new value. And why? Because certain programming, certain instructions needs to be executed frequently. So why microprocessor needs to every time go to the RAM and ROM addresses? If that instruction which is frequently used by the processor, it's saved onto a separate device, which is called the cache memory device. And if it is needed frequently, it can access that particular instruction or access that data, so that the speed will be very faster. Okay, the communication will be very faster. So That's why the cache memory is implemented, and always the old values will be removed, because cache memory has very less capacity. It has the size is small, very small size, and the less capacity. So total program or total instructions for a processor or for a CPU is not stored inside the cache memory. Some portions are stored, and that is duplicated from the main memory. Okay, so that's why this cache memory is always it has the less capacity to store the information. So if cache is full, that means some portion you must be replaced with the new instruction, because you need, if you need the instructions which is frequently used, but you have not space in your cache memory, what you need to do, you must flash out the old values. So the old values which are not frequently used by the processor, that must be replaced by the new one which will be used in near future frequently. And all the cache memory, it is based on the property which is called the locality of reference, or principle of locality. Okay, so what is this principle of locality? That is, uh, suppose if you want to analyze a large number of program, that large number of program shows that the CPU reference to main memory during some time period tend to be confined with a few localized areas in memory, or much more than this. So in what is actually I mean that the few instructions in the localized area in memory are executed repeatedly for some time duration, and other instructions are accessed infrequently. Okay, so this phenomena actually known as the uh, locality of reference, or it is called the principle of locality. And this property actually used when a program loop is executed. So when any loop is executed, the processor repeatedly refers to the set of instructions in memory that constitutes the loop. So if you create a loop, if you have created a loop, certain instructions are executed repeatedly. Okay, so this loop tends to localize the references to memory for fetching the instructions. Okay, so that is called the locality of reference. So here it is given as the programs access a relatively small portion of their address space at any instant of time. So certain areas have to be repeatedly executed. And there are two types of locality of reference, namely temporal locality and spatial locality. So in temporal locality, what is happened, if an item is referenced, or if any type of instruction is executed, or it is referenced, then it will tend to be referenced again soon. That means recently referenced instructions are likely to be referenced again in the near future. This is often caused by special program constructs like iterative loops or subroutine calls. So once a loop is entered or a subroutine is called, a small code segment will be referenced repeatedly many times. So the temporal locality tends to cluster the access in the recently used areas, and that is the temporal locality. Okay, so the item or any type of instruction or data which will be used frequently in near future, that is called the temporal locality. And the next is the spatial locality. What is it? If an item is referenced or any instruction is referenced, and whose addresses are close by will tend to be referenced soon. Or in other words, it can be termed as, this refers to the tendency for a program to access the instructions whose addresses are near one another. Okay, so addresses are near one another, like for example, operations on tables or some arrays involve accesses of a certain clustered area in the address space. Now, program segments and other types of routines, which is to be stored in the same neighborhood of the memory space. So after accessing this, if it needs to access the nearest locations, some of the locations nearest to this current execution, then this position is called the special locality. Okay, so actually, so what is the difference between temporal locality and spatial locality? Temporal locality, actually it is refers the instructions that are likely to be referenced again in the new future, in the near future. But in spatial locality, what is to be done? It refers to the tendency for a program to access instructions whose addresses are near to one another. Okay, not only the specified instruction but also the nearest instruction addresses must be uh, considered. Okay, so here the transformation of data from a main memory to cache memory is referred to as a mapping process. It's a mapping process. And how this mapping process can be done, uh, this will be done. I have Okay, so I will discuss the mapping process later, but before this one, you must familiar with some terminology with respect to this cache memory concept. And these are, first one is a block or line. That is the minimum unit. What is the block or what is the cache line actually? Cache, uh, what is it? The minimum unit of information that can be either present or not present in a cache level. Okay, so from main memory, certain amount of instructions or data, whatever, the information must be stored inside the cache memory, not the full program or the full information which is stored inside the main memory. So because the cache memory is it has very less capacity to store information compared to the main memory has the largest capacity to store information. So certain portion will be stored. So minimum unit of information that can be either present or not present in a cache level is called the block, or is called the cache line, because the block size may vary from machine to machine. Okay, so what does it mean? That means the operation of the cache is conceptually very easy. And like this one, that when first the cache memory is accessed, when the CPU needs to access memory for a word, it must be accessed from the cache memory first. If the word is found in the cache, the CPU reads it from the cache memory. And if the word addressed by the CPU is not found in the cache, the main memory is accessed by the CPU next to find the word. So due to the property of locality of reference, a block of words containing the one just accessed is then brought into the cache memory from main memory. So that means it may be present or may not be present inside this cache, and that is called the block. And this block size is varied from one machine to another machine, one processor to another processor. It is another term which is often used to refer to a cache block is called cache line, also cache line. And another term which is related to the cache memory is called heat. So what is heat? Heat means an access where the data requested by the processor is present in the cache. that is the heat. So when the CPU refers to memory and finds the word in cache, it is said that a hit occurred. It is said that hit occurred. If it is not present inside this cache, if the word is not found in cache, then the CPU refers to the main memory for the desired word, and it is referred to as a miss to catch, uh, to cache. Okay, so hit and miss is there. If it is found inside cache, it is called hit. If it is not found and processor needs to go to the main memory to search for it, it is called as miss. And the hit time, that is the time which is needs to access the cache memory block and return the data to the processor. So that means it is when a CPU goes to the cache memory to find a block of data, and after finding it, it must return with this data. The time is called, the total time is called the hit time. And what is the hit rate or miss rate? That means the fraction of memory access found in the cache is called the hit rate, or if it is not found, it is called miss rate. And along with one terminology which is very very important, that is the hit ratio, and that ratio should be calculated in this way: the ratio of the number of hits which is divided by the total CPU references to the memory. Hit plus miss total is the hit ratio. So hit ratio is the number of hits divided by the total CPU reference to the memory, which is equivalent to the number of hits plus number of miss. Okay, so that ratio is called the hit ratio here. So here is an example. It is an example of cache memory where the cache can store 256 words, each of each of 8 bits out of 64 kilobyte words in the main memory at any given time. Okay, so here this is the cache uh, that can store 256 words, each is 8 bits wide, and total main memory space is 64 kilobytes. Again, each bit is 8 bits. So out of this 64 kilobytes, only 256 words can be stored inside cache. So it is the duplicate. Actually, there is a duplicate copy in main memory for each word stored in cache. Okay, so what is stored in cache, that must be also stored inside this main memory. Okay, and it is changed by every time according to the operating system, whenever the instructions are needed by the processor to execute. The CPU communicates actually with both of these memories. The CPU first sends a 16-bit address to cache. Why 16-bit? Because 64k is equivalent to 2 to the power 16. So it gives 16-bit address to the cache. If there is a hit, the CPU accepts the 8-bit data from this address from the cache. And if there is a miss, then CPU reads the word using this bus. CPU reads the word from the main memory, and the word is then transferred to cache, and word is then transferred to cache, so that it is available in near future also. uh, Current execution will be based on this, as well as it stores into the cache. So if it is required further, so it CPU don't need to go to search inside this main memory. It can directly search it inside this cache, so that availability of this data will be more faster compared to this main memory searching operation. Okay. Then so there are three types of cache mapping techniques are available. These are three types of memories actually: associative mapping cache memory, direct mapping cache memory, a set associative mapping cache memory. Now what is the function of associative mapping cache memory? So here is your diagram. So in associative cache memory, so it uses the fastest and most flexible mapping method, in which both address and data both address and data of the memory word are stored. Both address and data of the memory word are stored, and this organization is sometimes referred to as a fully associative cache. Fully associative cache. And in this example, what happened? The cache memory can store 256 words as per the previous slide. This one here, the cache memory can store maximum 256 words out of 64 kilobytes words from the main memory. Now in associative mapping, here any location in cache to store any word from the main memory. It allows any location in cache to store any word from the main memory. So the CPU first sends a 16-bit address for a desired word to the register, input register, here in this input register. So first it gives the 16-bit address to the input register, then and the associative cache memory is then searched for a matching address sequentially. If the address of the desired word is found, then the 8-bit data word, these are the addresses, this must be matched with the request address, and if that address is found, so the corresponding data uh, is read and send it to the CPU. If no match is occurs, then main memory is searched for the address of the word, then address data pair is brought into the cache memory from the main memory, and place onto an old address data pair if the cache is full. So always this address data pair is brought into the cache memory from the main memory. If no match occurs, then main memory is searched for the address of the word, and if it is found in main memory, it must be copied from there and stored inside this cache memory. Okay, and if at that time if the cache memory is full, so how this data will be saved onto the cache memory from the main memory? By replacing the old data, some of the instructions which are not executed at that time, or frequently it is not used by the processor, so these instruction must be replaced with the new instruction or new data byte. Okay, so this replacement of old data byte with the help of new one, so there are certain algorithm, and these are called replacement algorithm. Okay, there are two types of algorithms are available. One is first in first out algorithm, another is least recently used algorithm, or LRU algorithm. So I will discuss these two algorithm later after a certain slide. So there must be some replacement of new data, new data by replacing it with old one. Okay, so old must be replaced by the new data bytes. If cache is full, if it is empty, means if there are more than enough space is available, then no need to uh, eliminate this old data. So old data must be there as well as the new data. Okay, so this is the associative mapping. So actually the advantage, what is the advantage of it? It is easy to implement and it is very fast. Okay, but the disadvantage of associative mapping is it is expensive compared to the RAM. compared to the RAM, because an additional storage of addresses with data in the cache memory, because of additional storage of addresses with data in the cache memory, it takes much more expensive than the RAM. Okay, so actually what is in this example, what is given, that we are